first graph they want you to draw is a 1 over x minus a graph. Okay, so to draw this, maybe you help me set up the axis first. Let's draw a very big one so that we can get a big graph drawn in. We get all the features, okay, drawn out nicely. So let's draw a y against x. Okay, one of the things that you will also learn next week when we do graphs will be that how do we get this vertical asymptote? A vertical asymptote appears because you let the denominator to be 0. When I let the denominator be 0, it will be undefined. Denominator cannot be 0. And undefined means you create a vertical asymptote. So for our situation here, this particular graph will have a vertical asymptote. Can I write in short form VA? Vertical asymptote is when you set the denominator to be 0, and so x is equals to a. So if I were to draw this first graph, there will be this vertical asymptote. You draw in dotted line for the vertical asymptote at position x equals to a. We don't exactly know how much the graph will bend, but I know that it will still be on the top right and bottom left segment of the graph. The graph is just shifted by a units to the right, basically. When you let this denominator be 0, vertical asymptote is a. So this graph that I am drawing is y equals to 1 over x minus a. The other graph of interest is this modulus graph. Remember, modulus graph will have a vertex. This graph, basically, the shape is a V shape. This point is called a vertex. When do we, or how do we find a vertex? You will set the mod part to be 0, which means in this case, we will have your x minus a to be 0, so x is a. Hence, you get a V-shaped graph at x value a. This is x value a. We do a V shape at this position, so it will go up on the right and go up also on the left side of the graph. The graph that we are drawing here is y equals to b mod x minus a. In terms of drawing the graph, we are done. Let's now use it for part 2, where it's a hence problem. So hence, can we solve this inequality? I want to have the first graph to be less than the second graph. When they give you this kind of less than, it's referring to the y values. So think about the y values of the first graph lesser than the y values of the second graph. When is that occurring? So when is your black graph lower than the blue graph? I just highlight on the black graph. On the black graph, this part is lower than the blue graph, and also this particular segment. These two yellow parts of the black graph is lying below the blue color part. Okay, so to solve for the inequality, I need to make sure that we calculate what is this intersection point. This intersection point will then mean that I want x values to be more than this. Okay, so to calculate that, we want to intersect the two graphs. But there is a modulus, so that's why there will be a need to understand more. How do we remove the modulus? We did that in the earlier part of the lesson. This right-hand side of the graph has got positive gradient. The left-hand side of the graph has got negative gradient. We are trying to open up the modulus. I want to remove the modulus. So if I remove the modulus and it has positive gradient, the equation will be b times x minus a. I need the mx plus c, the m value, to be a positive number, and b is positive. So on the other hand, the other graph on the left side would be negative b times x minus a. It has a negative gradient, it's coming down. Okay, so let's find this point. Okay, I just write it on the right here. We are going to intersect your y equals to 1 over x minus a with y equals to b times x minus a. We're going to intersect these two graphs. Okay, so let me write in them together. We want to solve for the x, so I'm going to multiply the x minus a to the left so that we get a square. I move the b over to the right. We can do a square rooting. We will get a plus minus. And we make x the subject. So should it be the plus or the minus? Can we understand a little bit more? The value that I have here is larger than a. A is at this point. My point is larger than a, so it must be a plus a certain constant. Okay, hence that value on the right is actually a plus 1 over root b. It's a number that is bigger than a. Okay, so just for understanding purposes, you don't need to draw this in. How come there are two answers? It's because we were intersecting the entire line. This entire line intersected will surely give you a second intersection point. Okay, but you don't need to draw out that second segment. Okay, we only look for the top right answer. Okay, so once I fill it in there, I can now code the inequality. Okay, let's put in a final answer. By looking for the yellow color regions, so your yellow color regions will be x less than a or x more than your a plus 1 over root b. Those are the two yellow colored regions for their x values.